Hi, this is Tim from the Ford Astronomy Club, and I thought I would do a computer simulation of the pass-by of Asteroid BL86, that 2004 BL86. I know the name doesn't exactly roll off the tongue. That's going to be doing a flyby of our planet this evening. It's actually doing a flyby right now, but as it's daytime, as I'm making this, we can't see it in the sky. But this evening we'll be able to see it. The closest it comes to the planet is about 3 times the distance to our moon, roughly. And estimates on the size, we don't know these things precisely, but the estimate is that it is probably about a half a kilometer in diameter. As asteroids go, particularly near-Earth asteroids, that's really big. If an object that size hit our planet, it wouldn't matter where it hit the planet, and it wouldn't matter where you lived on the planet. It would be a very bad day for everything on the planet. So that would do considerable damage planet-wide. By the way, up at the top of the screen, I'm sort of waving my mouse around. You can see the first quarter moon up there. This line that sort of arcs across the sky is the true orbital path of the object. So what I've done is I've gone and got the orbital parameters for this object. We call that orbital ephemeris data. And it's a mathematical way of describing an orbit, and I'm able to punch that into my software, and it's able to show me exactly how that object will behave as it goes by with those orbital parameters. So there is a tag down here in the lower left, and that shows a little arrow shows the location of the object. You can see it's behind these trees. I've set this start time to this evening, January the 26th. At 6:15 p.m. Why 6:15 p.m.? Because that is the time that the object rises above the horizon. Now, my horizon is a simulated view of trees, so it's technically behind the trees. If we were to simulate that we mowed those objects down, we would see it. The sun has technically already set based on my computer simulation, but we still have quite a bit of twilight in the sky. So these stars, I've gone ahead and turned on the stick figures and labels on the constellations. You can see Orion prominently here. Off to the left side, left edge of these trees is the constellation Cancer. You're going to want to pay attention to that constellation as it comes up because that's the direction that it's headed. Though you do see this line, this is not the path. This is the true orbital path, but that's not the path that this object is going to follow as it appears to go through the sky. I'm going to turn on a couple of options for you. So the first option I'm going to turn on is called the local path. That's going to draw a green segmented line indicating the path across the sky that it's going to seem to take. I say seem to take, that's because while this object is technically moving through space, the Earth is spinning around beneath your feet. So it's moving, and also we're moving. Now the stars in the sky, though they are technically moving, they are so incredibly far away from our vantage point that in the scale of an entire human lifetime, they seem not to move at all. They do. They move a very, 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 very tiny bit, but you would have to live many lifetimes to notice that they were moving. So for all practical purposes, you can pretend that stars don't move. And then I'm going to turn on one more feature called the celestial path. And that is going to show the apparent path of the object moving against the background stars. And that's probably the more interesting path to watch. With that, let's go ahead and turn this on. The software that I'm using to simulate this is called Starry Night Pro Plus 7. And over here on the right, this number 300x means that I have told the simulator to run at 300 times normal speed, which means every 1 second of real time that elapses 5 minutes. 300 seconds is 5 minutes of computer time is going to elapse. So let's go ahead and just put this in motion without further ado. And here comes the object coming up. You're going to see the dusk is starting to darken down, and we'll be able to see the stars come out. And there's Cancer, the constellation Cancer, the crab, off to the upper left of this. And if you notice, this red line here is actually heading in the direction of Cancer. And the timestamps are being written on these paths. I have them recording now. So we're up to, well, we're coming up on 9 p.m., not quite there. At about 12:30, however, this object is going to go by this fuzzy little spot that you see here. I'm hovering my mouse in the area around Cancer the crab. That's actually the beehive cluster. In fact, let me see if I can just turn that label on for you. There we go, M44, the beehive cluster. And I'll go ahead and continue the clock running. By the way, the beehive cluster is a beautiful binocular object. You don't even need a telescope to see this thing. Let's go ahead and stop the simulation just so I can reorient the sky. I'll let this run until about 12:30 a.m. and so we're coming up on the midnight hour now. Not quite there yet. And that's about midnight. And you can see it's going right past the center of Cancer the Crab. And there we are at 12:30, and it's going right by the beehive cluster. It doesn't quite go through it, but it just sort of grazes the edge of the beehive out in space. A beautiful binocular object to take a look at. So there you go. That's a sort of a simulation of the path. I hope that makes sense to you, of this asteroid flyby that we're going to have. That's it, and I hope you've enjoyed.